Hello everyone. So today we will be solving Leetcode problem 189 rotate array. Okay. So first we will go through the description of this problem and then we will see the implementation of this problem. Okay. Let's see the description of this problem. So we have given an array. We have to rotate the array to the right by k step. Okay. Where k is non-negative. Okay. What does it mean? So we will understand this thing by this example. Okay. So we have given this array 1, 2, 3, 4, 5, 6, 7, and k is 3. So we have to rotate this array to the right, which means after first rotation, this 7 will go at the place of 1 and every element will shift one by one. We will see at the board as well, but right now I am explaining that thing by this example. Okay. So we will get this array. Okay. Yeah. Now next step, because we need to move k steps. Okay. Now 6 will go at the start, as you can see, and every other element will go to the right. Okay. This will be our output in that case. Now the third step is k. Okay. K is, because k is 3, so we need to take the third leap as well. So when we took the third leap, this 5 will go at the start and every element will shift one by one. So this is our required array. Okay. Let's see for this example in both. So we have given this array. So here k equals to 2. Okay. So first, as we have to rotate it right, what we will do, we will have this array. What we will get, we will get 99 comma 10 minus 1 comma minus 100 comma 3. Okay. How does it move it? So it is starting from 99, because we need to move to two steps. So first this 99 will go to here, and then every element will move one step. Okay. And this 3 will move here. So this is the first step, and this will be our resulting array. So when this is the first step, then k will be 1. Okay, because we took first step. Now k will be 2. So if k will be 2, how does it move? 3 will go to this. Okay, because we have to move to right. Okay, remember this thing. 99 here, this one here, and 100 will be here. So what will be the resulting array we have? Okay. So our resulting array will look like 3 comma 99 comma minus 1 comma minus 2. This is fine. So how we will be approaching this question? Let's see that. Okay. So we need to rotate it by k times. Okay. So there are couple of ways we can do it. Okay. First we will see the recursive solution for this problem. Okay. In recursive solution, what we can do. So I'm making a text box here. Minus 1 comma minus 100 comma 3 comma 99. Okay. Comma 3 comma 99. Okay. So as you can see, what I will do, I will reverse this array. Okay. Or I will reverse this array. Then what I will get? I will get 3 minus 100 and minus 1. Okay. This will be our reversal of this array. Then what I will do? I will reverse k elements. Okay. I will reverse k elements from this array. Okay. Let's see how it will work. Okay. So I will reverse k element from this array. Yeah. When I will reverse k element, it will be like 3 comma 99 comma minus 100 comma minus 1. Okay. This will be our resulting array. So, and then I will reverse other half, because we have, like, suppose n is the length of the array. N is length of array. N equals to length of array. So in this case, our length is 4. Okay. and k equals to 2, 2, which means what first we do? We reverse this array. After reversing this array, we reverse the k element. Now we need to reverse the n minus k element. So in this step, we reverse the array and then we reverse the k element and then we will reverse the n minus k element. Okay, so how we will reverse? Because we already reversed this, and this will run to 0 to k. It will run for 0 to k, and this will run from k to n minus 1. Okay, this will work like this. So now our array will look like minus 1 comma minus 100. Okay, and this is the output. Okay, so how we will proceed? Actually, if you observe this thing now, you can easily recognize this pattern why we are doing this. Okay, so we are reversing this array. Okay, and then we are reversing the first k element and then we are reversing the next k element or n minus k element, because this is because here k is 2, so we can say k element, but that's not the right way to do. Okay, we can easily define it like n minus k elements. Okay, so let's implement this approach, then we will discuss another approach where we will use some space. Okay, let's see the implementation for this approach. So first I will check like if our array is null or length will be less than 2. Why we are checking for length will be less than 2? Because if our array is null or if the length is 1, then there will be only one element and we do not need to do anything for that. We directly return it. Okay, we will return. Otherwise, what we will do? We will need to take care of one more thing, because here you can see like k will goes to 0 to 10 to power 5. So it there may be a case where k will be greater than length of the array, so we need to take care of that. How we are taking care of that? We will take the mod. I will explain this thing in next implementation where we will use the space nums dot. Okay, now I will make a reverse function, and that reverse function private void reverse. What it will take? It will take nums array and then it will take I comma int c. Okay, or you can say start or end. It's up to you how you are taking it. So what we are doing, we are just swapping the elements. Okay, as you guys can easily see that what we are doing, we are just swapping the elements. Okay, we are just swapping the elements. So this is our array. Okay, after reversing this is the array we got. Now what we had done, we are swapping these two elements. Similarly, at here you can see we are swapping these two elements. So that's what we need to do. Okay, so how we will swap? So we will take a variable named as temp equals to 0, and then we will run a while loop while I is less than j. I is less than j, and I will explain what will be the I and what will be the j. Okay, temp equals to nums of I, nums of I equals to nums of j, and then nums of j equals to, yeah, then nums of j equals to temp. Okay, and how I will proceed? I will increase, j will decrease. Okay, I hope this point is fine. This is how we will swap the array. Okay, I will do a try run for this reverse as well. Okay, I will do that. Now we will see how we will be reversing this. First we will have nums, then nums dot length minus k minus 1. We will reverse first half. Okay, now we will reverse nums comma nums dot length minus k and nums dot length minus 1. We will reverse the second half. Okay. Now at the end, we will reverse the whole array. Nums dot length minus 1. And submit this one. Okay. Yeah. You can see our solution got submitted. Let's run for other test cases. Okay. Just a minute. Yeah. It got submitted. Okay. So the solution got submitted and our complexity is not very high because we are dividing that array into k and n minus k part and we are reversing that array. Okay, I hope this point is fine. Let's see the other solution for this same problem. Okay, and I will explain in that why we are taking this k modulo num dot n. Okay, so let's see that solution. So I will take the same example, but here I will put it like k equals to 6. Okay, so tell me one thing. Tell me one thing. So after, like, suppose if we rotate it 6 times, what will be the output? Okay, we will get the same output which we get for k equals to 2. Okay, our output will be 3 comma 99 comma minus 1 comma minus 100. Okay, this will be our output. So but how we are getting the same output, why we are getting the same output, we will see that. Okay, let's see. We already checked for k equals to 2. Okay, now if this is the output for k equals to 2, this one. Okay, we already checked this. Now if k equals to 3, let's see for k equals to 3. For k equals to 3, what will be the output? We will get minus 100 comma 3 comma 99 comma minus 1. This will be the output. And for k equals to 4, what will be the output? We will get minus 1 comma minus 100 comma 3 comma 99. So did you observe something? For k equals to 4, we are getting the same array. Okay, which means after, like, what will be the length of this array? This 4. So when we are rotating any array, which, like, when k is equals to the length of an array, we are getting the same array. So that's why we are using k equals to k modulo length, because after particular iteration, after n number of iteration, or after length of the array, like if we are rotating our array n times, where n is the length of the array, then we are getting the same number. That's why we are doing it. Okay, when we modulo n, then, like, for k equals to 6, for this what we will get? We will get k equals to 2. So we need to find for k equals to 2. Okay, and whatever will be the result, that's our solution for this problem. Okay, so that's why we are using this. Okay, so instead of repetitively doing the same thing, we could do this, and it also reduce our complexity. Okay, this is one of the, that's why we are using it. Okay, now we will see the other approach, which is a space optimization approach. Okay, so what we need to do? So what we will take an array. Okay, we will take an array of same length. Okay, I took an array m, which will be, length will be equals to 4. Okay, this will be the length of array. So how I will proceed? How I will proceed? So if you observe, like, here you can see, easily see, after two iteration, because k equals to 6. Okay, when we do k modulo 4, what we will get? We will get 2. So after 2 rotation, our output, like, our array will look like this: 99 comma minus 1 comma minus 100. Okay, our array will look like this. So did you observe any pattern? Like, at the place, at the 0th index, what we are getting? We are getting 3. We are getting 3, which means what we are getting? If I could add, I plus 2, if I could replace this value with I plus 2 index, and I don't think I need to explain this why we are adding 2, because k equals to 6 and k modulo 4 equals to 2. Okay, so that's why we are doing it. Okay, I hope this point is pretty clear from the last example, so I do not need to explain this point again and again. So that's why we are adding this to index. Okay, so if we are getting this value and we are replacing it, okay, or we are what we can say, yeah, we are replacing it or rotating it. Okay, some same thing. Okay, so this is how we can do it. Okay, so let's see, suppose temp of, so I will run a loop for I equals to 0 to I is less than 4. 4 is our length of array. So I will just, I am not doing for a generic, I am doing for this, so you guys can do it if you want. Temp of I equals to, temp of I equals to nums dot length minus 1, nums dot length, and what will be the value of k, minus k plus I. Okay, this will be our answer. Okay, I hope this point is clear, and this is how we will get this array, and we need to return this array or whatever will the answer. After rotating it, we can do that. Okay, so this is how we will rotate it. Okay, let's do a try run on this. If I equals to 0, what will be the value of temp in I? Temp of I. Temp of I will have, or temp of 0 will have nums dot length, which is 4, 4 minus k equals to 2. We already calculated 4 minus 2, 2, which will be nums of 2. Okay, and what is the value of nums of 2? Equals to 3. Okay, let's see, temp of 1. Okay, now nums of 3. Okay, what will the value of nums of 3? Equals to 99. Okay, temp of 2. Okay, now equals to nums of 4. Nums of 4, but do we get nums of 4? No, we don't get nums of 4, because 2, 3. Okay, but here 4 minus 2, 2, and our index will be 2, 2 to 4. So do we get nums of 4? No, we again need to use the same thing. We can use modulo here. Okay, so when we are doing this thing, what we can do, we can use the modulo of nums dot length, of nums dot length. Why we are doing this? Because we need to take care of the overflow as well. Okay, so if we are doing this, we could easily take care of the overflow. And here you can see nums of 2 equals to, it will get minus 1. Okay, similarly for this one, nums of 3 equals to, temp of 3 equals to nums of 5. If we do nums of 5, because we don't have fifth index. Okay, we don't have fifth index, but if you calculate for 3, 3 minus 2, 1, 1 plus 3. Okay, yeah, 4, 4 minus 2, 2, 4 plus 3, 5, 5 modulo, oh, this will be the modulo operator. Yeah, 5 modulo 4, we will get 1. So we have to give this first index. At first index, what we have? We have minus 100. Okay, so this will be our output. Please try it and using this solution. You can either you can use this or you can use this. Time complexity will be same. The difference is the space complexity. So currently for this solution, our space complexity will be O of n. So that's why if interviewer asks you to reduce the space complexity, you can use a recursive one. Otherwise, this is a pretty simple and straightforward solution. You just need to use the modulo operator effectively. Okay, thank you for your time.